What's happening? Algebra 2, moving into 1.5, solving inequalities. Okay, so the only objective we got to reach today, guys, is solving one-step and multi-step inequalities. All right, so some of these are just going to have a really simple one-step thing, and then we're going to have multiple steps in others, but at the end of the day, we're just solving inequalities, which we've done a lot of before in Algebra 1. So a little quick review here. So inequality, that word, okay, inequality just means something that is not equal, right? Two things that are not equal to each other are inequalities. So if I have something that's less than or something that's greater than something else, that is an inequality. Okay, so probably heard that word in the news lately, maybe. We hear it in other places more than just math. It comes up in politics. It comes up in all sorts of areas. But all of it meaning very much the same thing when two things are not equal. Okay, so little quick reminder here. This sign, okay, and this sign, a lot of people get confused for some reason. The one that looks like an L, so like if you just, notice if you just adjust this a little bit, right, and if you were to write it just that way, if you just turned it a little bit, it creates an L. If you do the same thing on this other one, it would be a backwards L, and that would not make sense. So the one that's like an L, that is the less than sign. This is the greater than sign. Okay, so know the difference between those two. And then remember that if we put a line under that means that it's greater than or equal to, or less than or equal to. And then I'm going to show you guys how to graph those as well. So going into graphing right away, when we're graphing inequalities, remember that an open circle just means that it doesn't include the number. So if I said something like x is less than 3, okay, so here's 0, 1, 2, 3. Okay, if x is less than 3, you have to consider the fact that 2.9999999 is also less than 3, right? So if I'm including all values less than 3, this guy has to be included on the graph. So how I include that is, without including the 3, is I leave an open circle at 3, and then I shade in everything else to the left, since this is a less than, right? So the number 2.99 is shaded in, right? 2 is, 1 is, 0, and then all the negative numbers, obviously. Okay, then for the closed circle, what that means is we're going to include the value. So if I said, okay, what if I want x values that are less than or equal to 3? Okay, if that's the case, and this is 0, 1, 2, 3, at 3, if we want to include the 3, we're just going to fill that circle in. So the big difference here is make sure that you are very clear when you guys are graphing whether or not you're dealing with an open circle or a closed circle. I have to be able to see it, see the difference, okay? So make sure that you really fill in those closed circles and really kind of exaggerate the open circles so that we can tell. So when we're solving inequalities with addition and subtraction, okay, so if we're just performing the operations of addition and subtraction, we're just going to solve it like any other equation. We're just going to isolate the variable and keep the inequality sign the exact same. I say that, but what I would like to encourage you guys to do is I would like to encourage you to solve the variable and always keep the variable on the left side. So if you end up with something like this, all right, if you end up with like 5 is greater than x, okay, I would encourage you to always write the variable first. So that means this is going to mean the exact same thing as long as we keep our sign. A lot of people call this thing the alligator, right? The alligator mouth. If you guys see that, like this is the mouth of the alligator, right? The alligator has to continue to eat the same thing. So if this is a true statement, then if I want to write the x first, notice that inequality sign does change, but this means the same thing because the alligator here is eating the 5 just like it was here. All right, so let's do some examples of that. Example 1 says, to solve the inequality, graph the solution set on the number line. So you have a ton of these to do in your homework where you're just solving these and then graphing them. So we're just going to solve it like everything else. Okay, so we're going to try to isolate the variable. Let's move the 4w over on both sides, and then we'll subtract 3 from both sides. Okay, so we'll do that operation there. I'm going to do it all at once. So this goes away, this goes away. 5w minus 4w is w, which is greater than 9 minus 3, which is 6. Okay, so we have w is greater. Why did I write a 3 there? W is greater than 6. Okay, so in order to graph that, what I want to do is I want to identify where 6 is. And if I give you these blank, like graph type things, guys, just label like a couple numbers so I know like the direction that you're going and stuff. I don't need you to label every single little thing. But let's just like be clear about it. So this is like 3, we'll call this 3, 4, 5, 6, 7, something like that. That will give me at least clarity of your number line. And if the values are greater than 6, but not equal to, we're going to have an open circle, and we're going to go this way. By the way, if you do solve these inequalities and always have your variable on the left, this thing does act, the inequality acts as an arrow. So note, this only happens if you're, I shouldn't even say this because some people use this as a cheat and then they mess this up. But just be very careful with this. If the variable is solved on the left-hand side, then this inequality here, this will always point the same direction as your graph. So notice it's like an arrow pointing this way, and then our graph starts at 6 and goes this way. Just a little bit of a cheat there. But remember, your variable has to be solved, and it has to be on the left side. Okay, it has to be on the left side. So let's do this one. I'm going to subtract 4x from both sides, and I'm going to add 3 to both sides. This goes away, this goes away. 5 minus 4 is 1x, which is greater than 2 plus 3 is 5. So we say x is greater than 5. Okay, so 3, 4, 5. 5's right here. This is not or equal to, so we're going to have an open circle, and we're going to go to the right. All right, so that is example 1. Let's keep cruising here. It says solving inequalities with multiplication and division. So one thing to consider when we're doing multiplication and division, this is moving into example 2 here now, is that with multiplication and division, whenever we multiply or divide across an inequality, okay, by a negative number, we have to reverse the inequality symbol. Okay. The reason for this, and a lot of people get this confused and I make a big deal about this in Algebra 1, is, think about this, you guys. In the negatives, right, if I have negative 12 and negative 24, which one is the bigger number? Some people are very tempted to say, oh, 24 is bigger, so this one must be the bigger number. But turns out, when we go into the negative, that actually becomes the smaller number. Right? This value is actually less than this value, right? Because negative 12 is further on the right on the number line. Just imagine this too, like you have less money if you're $24 in debt than if you're $12 in debt, right? So think of them like kind of like debt. So since the negatives are this way, if we divide or multiply across the inequality, and that's important that if this happens when we do it across the inequality symbol, then we must flip the sign. We must flip the inequality. Okay, and this is the big reason why. So example 2 here says solve the inequality, graph the solution set on a number line, and then check yourself. So here we go. Let's do it. In order to solve this, we got to get x by itself. So we got to divide both sides by negative 4, right? Divide by negative 4, and then we get x. Now here's where you got to be careful. Whenever you divide or multiply by a negative, you're going to flip that thing, right? So we're going to switch the inequality. X is actually less than or equal to 6. All right. And again, if we do this out, okay, so think about this. It's saying the solution to this will be all values where x is less than or equal to 6. So let's call this 6, 5, 4, 3, 2, 1, 0, negative 1. Okay, so terrible 4 there. me fix that. Okay, so if this is saying x is less than or equal to 6. Okay, so let's plug in, fill that circle in at 6 and go this way. Okay, and let's see if it makes sense. It's always a good idea to test this now. So we can choose any value we want here. I like to choose 0 because it's easy. So if I plug a 0 in, let's see it to our original problem. Let's see if it makes sense. Negative 4 times 0. Is that greater than or equal to negative 24? So when I do this out, I get 0. Is 0 greater than or equal to negative 24? Yes. I would rather have $0 than be in debt $24, right? So there's a way to check yourself. It's very simple. So for 2b, let's do this one now where we solve for y. We're going to divide both sides by negative 9.2. Oh, great. They're going to make us use a calculator here. Okay, so this is going to cancel, and then we're going to have y is greater than, but not or equal to, notice on this one, right? So if I take 23 and divide it by negative 9.2, 9.2 negative, just putting this in my calculator, we get negative 2.5. Okay, so if you're going to graph that, guys, you could do this okay in the middle of a number, that's fine, but what I like to do is I like to go to halves if it's like a nice half like this. So what I might do is just do this. Let's call this 0, and then let's call this negative 1/2, negative 1, negative 1.5, negative 2, negative 2.5, or 2.5. And it's saying the y values are greater than that. So we're going to put an open circle there, and we're going to go this way. Okay, I don't mind if you use whole numbers, I guess, and you go to the middle, like in between two whole numbers. That's okay as well. But I just wanted to be clear about that on this one. So example 3 now is starting to get into the second part of our objective for the day. All of the ones up to this point have been like one step. Okay, the only difference with example 3, you guys, is now we're just going to add steps. Okay, so now we might have to do some addition, subtraction, multiplication, division all in one problem. All right, so we still want to solve for x. But notice I have x's on both sides here. So if I'm going to solve 3a, the best way for me to do that is going to be, I could divide both sides by negative 3. Or that's the same exact thing as multiplying by negative 1/3, right? So if I multiply negative 3 over 1 by negative 1/3, notice that this cancels with this, right? And our negatives end up canceling and we get 1, right? So negative 3/1 times negative 1/3 gives me 1. So here I can divide by negative 3, which is the same thing as multiplying by negative 1/3. So I could do that, but since I have x's on both sides, I think the better solution here would be to just multiply. Let's first just multiply both sides by 5 and get rid of the fractions. So if I multiply this by 5 and multiply this by 5, I get negative 15x is less than or equal to negative 4x plus 22. So I just got rid of the fraction. Okay, now I want to move this guy over here to combine x's, so I'm going to add 4x to both sides. Okay, so if I do that, I get negative 11. Careful there, right, because we're adding, so we're going closer to 0. Negative 11x is less than or equal to 22. And then we're going to divide both sides by negative 11. Okay, so then we get x is now greater than or equal to, notice when I divided by the negative, I swapped that thing. This is going to be negative 2. So on 3a, when I go to graph this thing, what I need to do is I need to have a closed circle at negative 2. So let's put 0, negative 1, negative 2, closed circle. And it says the x values are greater than or equal to that guy. So we're going to go this way. Okay. All right, for 3b, very similar. Let's get rid of the fraction first. So we're going to multiply by a negative 4 on this one. Okay, so notice we're multiplying by a negative. Whenever we do that, we're going to swap the sign. So we have negative 32y is less than or equal to negative 5y plus 9. Okay, then we're going to add 5y to both sides. Ooh, I'm glad this problem's coming up. Okay, so when I do this, I get negative 27y. And then on this side, I'll have 9, right, because this goes away. And then I'm going to divide both sides by negative 27. So notice I've already flipped the inequality once. And when I do this, I'm going to have to flip it back. So y is now greater than or equal to negative 1/3. So I've had that question in the past. Like, if I flip it once, can I flip it again? Yes. Anytime you go across the inequality with a negative and you're multiplying or dividing, you're going to flip it. So sometimes we do it twice, like we did in this case. All right, so here, I guess we can go into thirds here. So 0, negative 1/3, negative 2/3, negative 1 is how that would go, I believe. So this is saying y is greater than or equal to negative 1/3. So negative 1/3, I'm going to put a solid, and then I'm going to go this way. Okay, last one. Oh, there's 2 more. Okay, I'll do 2 more with you guys, and then you are on your own. So for this one here, we're going to distribute this out, right? So this is 24v minus 18 is less than or equal to 20v plus 6. I just distributed, right? Okay. Now I'm going to combine my v's. Okay, so let's do that. And let's also put my whole numbers all on one side. So this goes away. This goes away, and I get 4v is less than or equal to 24. V is then less than or equal to 6. Okay, so let's call this 6 on the number line, 5, 4, 7, 8. So this is saying the x values are less than or equal to 6. We're going to fill that circle in at 6, and we're going to go that way. Final example. Same thing here where we distribute out. So we have negative 15d plus 35 is greater than 6d plus, what is that, 242? Okay, so then let's combine. So we're going to subtract, I'm going to add 15d actually to both sides, and then subtract 42 from both sides. This is going to go away, this is going to go away. 35 minus 42 is negative 7. Is greater than, this is going to be 21d, divide both sides by 21. Now notice what happens here. I'm glad this came up as well. We have d on the right side, which we really haven't done up until this point, and then negative 1/3 on this side. So if I want to write this the same way every time, I'm going to put my d over on the other side. Remember that the alligator has to continue to eat the negative 1/3. So I'm going to put the d over here, the negative 1/3 here. The alligator has to switch signs there, but only because I'm rearranging it, not because I divided by a negative. So keep that in the back of your mind. And then to graph this, here's 0, here's negative 1/3. Let's just say we have an open circle here because we don't have an or equal to, and then it's saying that the d values are less than that. So we're going to go this way. All right, guys, the homework has definitely changed. I have homework sheets for you guys. We'll see you guys next time.